welcome guys. So today we have a question that is 88886 and let me increase the font. So question is saying the possible bipartition. Okay, so we have to do possible bipartition. Okay, so let's understand the question first, guys. So we want to split a group of n people level from 1 to n into a group of any size. So each person may like some other people and they should not go into same group. So given an integer n, an array dislikes okay, where dislikes are a of I and b of I, indicates that the person group level a of I does not uh, like any person level bi, and it returns true if possible to split every one into two group in this way. So if the example is saying that if n equal to 4, dislikes are this 1 2 1 3 1 4. So we are checking that and we are returning true. How? So group 1 is 1 4 and group 2 is 2 4. So what is happening here, right? So let's understand first what is the bipartite graph. Okay, how we can do bipartition, right? So how we do bipartite graph, we understood, right? Let's understand first. So this is the bipartite graph, right? And we have to understand here like what is happening in the bipartite graph. So this is the Wikipedia page. You can go through the overall concept behind that, right? So I will recommend that I have go through. You can go, you can try by your own. This graph you have to search on the Google, and on the image side you will see that I found this page is very good. Okay, so this is the page where I have gone through, and I will recommend you to go through this page, or let's go through first here. Okay, so it is saying that the bipartite graph or bigraph is a graph whose vertices can be divided into two independent groups. You can take set u and v such that each edge in the graph has one end in u and another and is v. Okay, so or in other word you can say either uv, which connects is a vertex from u to a vertex from v, or uv, which connect is a vertex from v to vertex from u. No edge will be connect to bipartite graph, and that belongs to the same set, you can say. So if you talk about this example, it is saying that if two sets, there is one set is in the red color and it is u and another is v, right? So as two sets of the uh, color color the graph, these so that all the vertices in u set u are in red color and all the vertices in v in another color. And now we can conclude that in bipartite graph or bigraph, all the edges have one vertex color red and another is black. So this is called bipartite graph or bigraph, we can say that this one. So in this example, if you will see that if both have the equal uh, cardinality, you can say that like means both set have equal number of vertices, right? Equal number of vertices. Okay, so then it is called balanced bigraph, and each vertex in set u have an edge to all the vertices in another set. Vice versa, then that bigraph, you can say, is called complete bigraph. Okay, so if both have the same number of equal number of, you can say, vertices, right? Both, then it will be the complete bigraph. When we talk about this one, bigraph cannot have the cycle with the odd length, right? So if we have odd a b c d, right, total, so if we are going to do like this, you can see that in this picture c and d are not connecting. C and d are connecting with the same color, but the another we have here in which we can see there is no connection with the same color. Okay, so it is saying that the bigraph can have cycle, that is no problem, but with an even length, not the odd length. Since in cycle even length is possible to have alternate vertex with the two different color, but the odd length cycle, it's not possible to have alternate vertex with two different color, right? So this is the case we have, right? So there is many things, and if you want to do matching, right? Matching the graph is a subset of its edges, not not these edges have any vertices, or other words, for each edge will connect two vertices, unique vertices, and this algorithm solve many matching problem, including maximum Bipartite matching that our question is belongs to. Okay, so let's understand here, and I think you have understood like what is the bipartite graph, right? So the question is like the problem asks us to divide the given people into two groups such that two people in the same group dislike each other, and we can represent these people in the form of graph with a people being nodes and dislike pair being edges, right? So our task is to figure out whether we can divide the nodes into two sets such that there aren't any edges between nodes of the same set. Okay, so we have to see that the graph, right? As you can see that these are the graph, right? These are the graph, right? As you can say, one is coming to A, it is going to what, 3, like this. You can say you have to think about the graph, right? So if in our case, okay, if in our case we can take like here, okay, if we talk about our case, okay, if b1 is connecting to who r1, okay, and similarly b1 is connecting with one more, that is r2, right? Similarly, if we have b2 that is connecting to what, that is connecting to what, r3, correct? And similarly we have we can take b3 b connect with any other number, you can take any other number. So I'll take r5, right? If we have b3 that is connecting to any number, you can take, so we can take r3 connecting with r1, right? And another we can take any number r4. So if you will make this graph, right, if you will make this graph, this is very, you can see that b is going to r1 and r2, b2 is going to r3 and r5, and b3 is going to r1 and r4, right? So in this way the nodes are split into two groups, right? All b1, all b are going to be what, either blue, and or r is going to be red, right? So within each group there are no connecting edges, right? Within each group, correct? And yeah, that's the reason what we can say, okay, all the nodes are now split into two groups, blue and red node within each group, and there are no connecting edges. And you have to do like this. How? You have to connect like this. If you consider this one, any of this node, right? Not this one, you can take, yeah, you can take this one example. If this all the blue color is your, or what, all the blue color is your B, and all the red color is your R, okay? So this will become your graph, right? So let's zoom out and start doing implementation, okay? Let's zoom a little bit. So we have given what, n, we have given n people, right? And we have to split a group of n people from 1 to n, and we have to make two group of any size, right? And that two group of any size, like dislikes, okay? So dislikes will be given and n is given, right? Now we have to return what, we have to return true if it is possible to split everyone into two group in this way. Okay, so let's let's see that. One more thing is saying that indicate that the person level AI does not like the BI. Okay, so we have to make in such a way the person AI is not liking what second one. Okay, B. So let's do it. So if we'll talk about the first approach, how many ways we can do that? The first approach is breadth first search. The first approach is breadth first search, in which what we can take, our task is to figure out whether we can divide the node people into two sets such that there aren't any edges between nodes in the same set, right? In the breadth, if we'll talk about the breadth first search, what we can take here, our task is to figure out whether we can divide the nodes, the people, into two sets such that there aren't any edges between nodes in the same set. So our intuition is what we can think of starting a traversal over such graph. We can put the first node into the first set and all the neighbors of the node into the second set, right? So now we can move one step further to the neighbors and put their neighbors in the first set. So we can perform the same process to keep alternating sets between neighbors. So we can use BFS here, BFS travel breadth first search, to assign the set to each of the nodes. So a breadth first search is an algorithm for traversing or searching a graph. It traverses in a level wise manner. All the nodes at the present level, say 1, are explored before moving on the nodes at the next level. You can say we can take level +1, right? Whether a level number is the distance from the starting node. So BFS can be implemented with a queue, right? So if you're not familiar with BFS, you can go to a simple program, right? And you can implement, okay? Or you can ping me if you don't know the BFS. I'll make one video and you can go through, okay? But BFS is very easy. You can take any example to learn. Next we have our task is to split the node into two sets such that there aren't any edges between the node of the same set. So let's start giving unique identification color to both group. To discuss them, we can use two color that we told you, red and blue, we can say, and we can like we have given B1 is all in blue and red one is all in R, right? So B1, B2, B3 here is what is in blue and R1 to R5 is what in red. So we can assign a color each node in such a way that all the neighbors node that share an edge do not have the color, otherwise it would result in a conflict. And to solve the problem, we can start a BFS traversal over the graph of people. Start assigning the color, you can say we can assign red to the starting node, and it does not matter which color we choose for the first node. The color blue should then be assigned to all the neighbors, and neighbors of the blue node should have the color red, and so on. So what we have to do, we can keep trying a color between neighbors, and in the implementation what we can use, we can use a number to identify each color. So let's, if we talk about, if 0 for red, so what will happen? 1 for blue, right? And to flip the color, we can use the formula 1 minus color. And if we were at red node, then 1 minus color equal to what? 1 minus 0 equal to what? 1. It means what? Blue. So if we, let me do here, okay, then you will understand. Means if we have a color, right, if we want to do flip the color, right, we can use formula what? 1 minus color, right? 1 minus color. And if we are at red node, right, what we can do? 1 minus color is what? We can take 1 minus color is 1 minus 0, because we have taken 0 for red balls and 1 for blue, right? And that's why color is what? 1 minus 0 equal to 1. Means what? Means blue. Like this we can do. So, or similarly, if we are at blue, what will happen? 1 minus color equal to 1 minus 1 equal to 0, and that will be our red, correct? So in this way we can do that. So there can be a multiple connected component in the graph, and we can visit, we need to visit all of them to, we can, means we need to visit all of them to make sure we visit every node. In a single BFS traversal, we will visit all the nodes, right? We will visit all the nodes present in one component, one connected component, you can say, and each color of them accordingly. So what we can do, we can make some possible examples, right, for a successful split and unsuccessful split of a graph. Having, you can take 3 component, right? You can take. So if we will talk about the algorithm, right, what algorithm will we have? We have to create an adjacent list, right, and that will be nothing but adjacent, and it contain all the neighbors of the X. Second, what will happen? We have to initialize any array color, and we have to store the color assigned to each node, and we have to initialize it to -1 for all the nodes to indicate no color have been assigned yet. Then in the third step, what we have to do? We will run a node, we will run a loop over all the nodes, and we'll check if there is any node I which is uncolored. So in the next step, what we'll do? We'll check if a node I has not been colored. Color of I is equal to -1, right? And starting a BFS traversal which will color all the nodes present in the same component as I. Then we will initialize a queue with I in the queue, and we have to assign the color to the source I, and we have to move to red -0, right? And then we will try to check if the queue is not empty, right? If that is not empty, then we have to dequeue the first node from the queue. We have to iterate all the neighbors of the node, and we'll check neighbor has the same color as node. If any neighbor matches, then we will have a conflict, and so we will return false. And if a color is not yet assigned in the neighbor, then we will assign the opposite color to it, and then we'll put into neighbor onto the queue. And finally, what we'll do in the BFS traversal has a conflict, then we will return false as answer. Otherwise, we will return true if we get through every node without conflict, right? So I think you have understood the code, understood the process algorithm, and then we will jump into the implementation, right? So I think this is not the uh, gr- uh, this is not the issue of resolving any uh, big problem, right? Because we have given n number of peoples, and we have what we can say, likes or dislikes of the uh, some people, right? So obviously you have to take care of your uh, node and your neighbor nodes, and that's what all. If you make the combination, means if one of the node is have the color, right, A or B, you can say red or blue, so the corresponding neighbor should not be the same color. And let's say first we will go through and they'll understand. I think I've taken more the time to understand, but I'm sorry for that. Let's continue to do in the BFS, right? How we can do that? So if we'll talk about, we'll take first a function here. What we can take, uh, see our function given, what we have given, possible partition, right? So in the possible partition we have given what, like and dislikes we have given. So if now we can start from here only, no problem. So we have given n and dislikes, so we will take adjacent node, right? Adjacent node will take equal to what, new has map, right? New hash map, right? And what will happen about the new hash map is nothing but a hash map, right? And that will take integer, and another will take a list of other node, right? Because see, B is going with a list of B, right? That can be many other nodes, right? So we can take list of integers, correct? And that is our adjacent nodes. Next, what we will take, we will make for loop, and we will have the dislikes, this, right? This dislikes, and we will traverse all the node, right? What will take, we will take int ages, and this is nothing but all the dislikes, correct? So we'll take int a is age of 0, as we have done in the last day. B equal to age at 1, correct? Then we have this adjacent, right? So from this adjacent we can find what we can find, we can use a compute function. I think there is a compute function, compute if present, right? Yeah, this one. And we'll pass first what, a, and then we'll take one value, and value is nothing but, it will point to array list of integers, correct? I think so, we can do that, and then we will do add b, we can do. And similarly, let me increase this size. I think I have taken a big size. Yeah, it's done. So as you can see that what we can take, a, this is our nothing but, sorry, this will be b, and this we can take A, and this will be our what? B. Correct. Compute if present, and then we'll add on the adjacent, right? Now if we'll come from here, we'll take int color, right? What is the color? Size, right? Int n plus 1 will take whatever the n number of people plus 1 will take, right? So we have our color now. Now if we'll talk about if 0 stands for red and 1 stands for blue, that we have talked about, right? So we can take 0 stands for red, right? And we have taken 1 that stands for blue, right? We have taken. So how we can do that? Initially arrays will fill what? Arrays will fill color is not assigned, that is -1. It means color has not been assigned initially. Okay, this is O0 I have to put, sorry. Okay, so how we have to do? We have to make a for loop to assign the color. We'll start with int I equal to 0. We'll take I equal to 0, and then I should be less than equal to what? N size, and I plus plus. In the loop we'll take if color of I is not assigned, means this. If not assigned, then what we'll do? Then for each pending component, run BFS breadth first search. And here means if color not assigned, that is the meaning. Okay, then what we will do here? We'll take if condition, and if BFS, we will create our own function BFS utility method, BFS utility method will take BFS, and that will pass the I, the adjacent, and the color we will pass. Correct? These things we will pass. So if we'll talk about here, what we will return? Return what? False. Why? If there is conflict in the component, if there is a conflict in the component, right, then we will return what? False. So let's return false. If that is not the case, right, that not the, if we are not getting what? Conflict, then will what happen? This loop will get completed, and then we will return true. Got it? You can say gotcha. Let's make this BFS, and I know that you have been aware of this. So we can take here or here. We can take here. I thought we can take there. Let's remove one space. I already have removed. So in the BFS, what we can do? We will take this functionality. So give the method. We can take public, or we can leave also. This should be boolean. To actually we are returning what? True or false. This is BFS. we'll take int I as a source. This is nothing but a source from where we'll go, and this will our adjacent node, right? So we have taken adjacent node, what? This. So I'll take this adjacent node definition from here, adjacent node, and then color is nothing but, what is color? This is our color. Okay, this is our color. Now coming to here, what will happen? We'll take first a Q. And this is nothing but our Q. Linked list we can take, not array list. That is our Q. Now this is our Q. We will offer Q, and we will add our source, and then we will assign the any color we can assign. I'm assigning 0, right? What we have taken 0 for red. I'm assigning initial value as a 0. You can take any color. We can take any other value. 1 also we can take, and that is nothing but we are start with making, what we are doing, we are starting with marking or marking source as, you can say, red color. Okay, now when we come to here, we'll make a while loop and we'll check if Q is empty, Q is empty, right? Then we will move, we'll take one node, and then we will do q.poll. That node we have already added on the queue, so we have taken. I will check if adjacent node is there. How will do that? If adjacent, not adjacent. If adjacent is not contains key, we can take and we'll pass node. If that is on the adjacent, then we will continue. If not, means we don't have, then we will continue, right? Now we'll take a for loop. Why will taking the extra space? Now we'll take int neighbor, and it will come from what? Adjacent, because we have already added on the adjacent nodes, right? List. We have added on the adjacent list. So if that is the case, we'll check if color of this neighbor is already assigned, is nothing but what? If color of that node is already assigned, correct? Means how we can check? With the color, right? We can check with the color of the node. We can check the color of node, and then what we will do? We will return false. Then return false. Means we have already tables, right? And we have already this color of this node, so we don't need to do that, right? Let's put down. Similarly, we'll take another if, and we'll check this color. If this color is, what we can take? Minus, means it's minus, then we have to set the color, correct? That we have did already, right? How we will do that? We'll take this neighbor, and we have taken the formula 1 minus color, right? 1 minus color of the adjacent node, right? 1 minus color. Now our component is fit. Now we have to add into the queue. To whom? Neighbor. Okay. If that is not the case, we will return here what? True. Right? I think this is in the if, and yeah, I think so. This should work. Let's compile is at 0, where we have taken edge edges. Yeah, it's fine. Yeah, very good. So let's one more time understand the program. Okay, we will start from here. What we have taken? We have given n and dislikes, right? So first we will create one adjacent list, right? Because see, in the algorithm, what I had told you, first we will create the adjacent list, right? ADJ that contains all the neighbors of the node, right? Then we will take here line number here. We'll take what? We will initialize an array color and store the color assigned to each node. We will initialize it to -1 for all the nodes to indicate no color have been assigned yet, right? And that's why I have taken here arrays.color means what? We don't have any color in the initially, right? So we have initialized an array color ever, and we have stored the color assigned to each node, and we have initialized -1 for all the nodes. Finally, we will make a loop. We'll make a loop to we will run a loop over all the nodes, and we'll check if there is any node I which is uncolored, right? Then we'll run if a node I has not been colored, right? Has not been colored. Then what we will do? We'll check if any node is uncolored, right? Then we will start BFS, right? We will start a BFS which will cover all the nodes present in the component as node I, correct? So I'm passing this node I as a source, and the adjacent and the color, and this method, the BFS utility, will check if the queue is not empty. We will dequeue the first node. We will dequeue the first node. How will do the dequeue the first node? This here, queue minus poll. We will do that. We will dequeue the first node from the queue, and will iterate over all the neighbors of the node. We will iterate all over the node and check if any node has the same color as the node, right? If any neighbor matches, then we have a conflict, and we will return what? False. Then we will return false. If the color is not assigned to the neighbor, assign the opposite color to it, then put the color onto the queue. That we have did here. We have assigned and then we have put onto the queue. Finally, in the if any BFS traversal has a conflict, that will give we will return false as answer. Otherwise, this loop will continue and will return true if we get through every node without conflict. So please like, share and comment if you like my solution, and please subscribe our channel to give us your support. If you have any questions, please ping me in the comment box, and thank you for here to listen me the full 40 minutes. Thank you so much.